A very good morning to one and all present here. Welcome you all to the 93rd session of WoW, the weekly online workshop. This program has been started by our Office State Project Directorate, Rusa, Tamil Nadu, almost 1.5 years back. In the program, our objective was to reach to the students of government arts and science colleges consistently, that is on a weekly basis, with a varied topic and a subject matter expert from a varied field. அந்த வகையில we have been having so many experts with us like entrepreneurs, bureaucrat, administrators, motivational speakers, life skill coaches, fitness coaches, and industrial experts also. And today, this is the 93rd session, and we are very glad to have Mr. Abhishek Leela Pandey with us. Welcome you, sir, to this session. It is really wonderful to have you with us today, and we are looking forward for the session. And the college joining us today is Government Arts and Science College, Papiredipatti in Dharmaburi district. So this is an interior district in Tamil Nadu, and the students are really going to be benefited with this session. And for the benefit of all of us, a short video on what this program is all about will now be played for a couple of minutes. Team, please play the video, team. Thank you, team, for the video. So this has been our journey all through this session. Our 50th session was graced with the presence of Dr. V. Irenba sir, and our 75th session was honored with the presence of Dr. Shailendra Babu sir, IPS. And today for the 93rd session, we have Mr. Abhishek Leela Pandey with us, and a short brief on sir for the benefit of all of us. Sir is a polymath, and he works in the field of pure and applied mathematics. He has created 9 theorems in the field of number theory and algebra, and has compiled it under a treatise called Brahma Ganita version 1.0. He is the Chief Academic Officer and trains management aspirants at iQuanta, a recognized edutech company under the Startup India initiative. Sir's interests are really broad, right from literature to acting to filmmaking. It's very diverse. He has authored and published 7 books ranging from fiction to poetry, mathematics. He involves himself in trekking and gardening at his leisure time. And today, a session with him on Love Thy Numbers is going to teach our students to break their myths on math. Maths has always been something for the one who has mastered it, it's like easy, and for the ones who find it difficult, it is always difficult. So இன்னைக்கு நம்ம ஸ்டூடெண்ட்ஸ்க்கு sir is going to help them realize how it can be approached easily. So I'm sure students will be highly benefited with this session, and we have more than 250 students with us today who are very eager to know what is it all about. Welcome you, sir, and thank you for all your time and effort spent for today's session. And now I request Dr. V. Sangeeta, Assistant Professor Computer Science from the college, to welcome the gathering.
Okay, a very pleasant morning to all.
Nice introduction. The video was really beautiful, and I thoroughly enjoyed it. I'm really glad to see so many people, and somehow I think I would be able to guide people into mathematics. Hello, Sangeeta. Yeah.
Yeah, Sangeeta ma'am, please, you can start now.
Yes, ma'am. A very pleasant morning to all. First of all, I welcome our respected principal, Dr. Ambarasi ma'am, for giving this opportunity to conduct this program through online mode. And I welcome our RUSA coordinator, Dr. Ravi sir. And also I extend my warm welcome to State Project Manager, Dr. B.S. Vijayalakshmi ma'am in RUSA. And I welcome Dr. Vanadi Vember ma'am, Research Officer in RUSA. And welcome Mr. Shivagami ma'am, Consultant in RUSA. And I welcome Gugan sir, Junior Assistant in RUSA, who arranged this program successful. Finally, I welcome our today chief guest, Abhishek Leela Pandey, who is going to handle the topic on love their numbers. Once again, I welcome all the HODs, staff members, and my dear students.
Thank you, ma'am. Thank you so much for the warm welcome. Dear students, one tip on the session: listen to sir keenly so that you can come out of the fear of maths. And students, my kind request, for some time, let's stop these emojis now and listen only to sir. I'm sure your faculties are inside and your principal is also logged in. So now let us listen to sir. Sir, you may please take over.
Thank you. Well, so I was talking to Vanadi ma'am, and we were discussing what can be done. There are different topics which came to our minds, and moonlight numbers, something which has got a mathematical, a literary aspect to it, the high numbers, Victorian English, which I think both of us like a lot. So people have different ways to live this life and to lead this life and to understand what life is about. People can go through motivation, people can go through films, through literature, through conversations, through trips, through tours. But some people are there who lead this life through a way called mathematics. The problem with mathematics and the way it is imparted throughout the education system across the globe is that whenever we open a book, there are formally the theorems, and then there are relevant questions, examples, and then you solve the questions and get good marks in your class 10, standard 12, or whatever. At the same time, if someone actually asks why mathematics is required, where has it come from? Why do we even need mathematics? That is the problem which I have felt a lot of people do not have a solution to. Well, there is a very famous quote, I'll start the session with that. It says, those who think life is complicated, those who think mathematics is complicated do not realize how difficult life is. Okay, so with that, I'll start the session. And mathematics is not complicated. Simple. The reason is because all the mathematical theorems have got a definite sense. So they are there or they are not there. So we don't have any confusion in mathematics. Well, so I'll start with something which is very basic, very fundamental. That is how I think we can walk through my mind and walk through the minds of people who find life in numbers, who find that numbers are their friends. So it happened, I was a kid, and it must have happened with all of you, be the students or the teachers, that when you were kids, everybody came to you, your family, your relative, any neighbor, and they asked, okay, how many marks have you got in mathematics? So nobody actually cared about English or any language or science. So first was mathematics. How many you have? How much marks have you scored in mathematics? That was something which was pressurizing for me as a kid, and I know for everyone actually. People did not know mathematics, a lot of them, and those who did, they were under so much pressure that now if we ask them that why 12 multiplied by 14 is 168, they won't be having the proper answer. It's just to take out the calculator, do some calculation, and tell the answer. There has to be something. There has to be a feeling behind 12 and 14. The product is 168. Well, so as I grew up, I realized that I am very bad at mathematics. It sounds ridiculous, but yeah, I was bad at mathematics because I could not score well. So I will tell you something about when I think 7 or 8 years old, and my mom, I belong to a family where there's a lot of emphasis on education. My mom is a doctorate, and she was always like, okay, learn this, learn that. So she asked me to learn all the multiplication tables. I could not do it. There were some patterns in some tables, like table of 9, multiplication of 9 has got a pattern. All of you know it. So you write 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and count the reverse of it. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is something which all of us, all the children, all the kids realize. Okay, this is happening. A simple pattern. The multiplication table of 9 actually gave me an idea or motivated me to get more into numbers. There is something that is very magical about it, isn't it? So when I grew up to learning tables above 10, for example, let's use something about 12. So 12 table, if you write it, 12 ones are 12, 22, 24, and so on. My mom asked me, I did not. And there's one more thing, which all of you must have noticed. So if someone asks you a multiplication table, you will go in series. 12 ones are 12, 12 twos are 24, and so on. But if someone asks you, tell me what is 12 into 7? At random. So then you will think, oh, 12 into 1 is this, into 2 is this, 3 is this. That's how you go about. That is something which our memory, how memory is structured inside human brain. It is basically in series. But once we try to manipulate the memory in such a way that we put in some logic to it, then our memory becomes permanent. So how I put the logic here, I won't tell you. 12 into 10 is something which our schools wanted us to remember. I tried to put the boundaries. But there are some take-home sessions for you. I'll be just, you can write it. The first take-home lesson is that you need to push your boundaries. Be it mathematics, be it anything else. If you push the boundaries, you'll get to learn more. Push the boundaries. So push the boundary of 12 into 10. I moved towards 12 into 11. And then I calculated, I got 132. Then push more. 12 into 12, I got 144. Now, here, I realized there is some pattern over here. Can you see the pattern? I was already again. 132. 12 into 12 is 144. 12 into 30 is 126. Pattern that I realized, the last digits are basically increasing by 2. They are even numbers, and the remaining digits are increasing by 1. 30, 14, 15. So automatically, when my mom asked me, what is 12 into 14? I said, let's put 16 and then put an 8. 160 was the answer. That was quite fascinating. Well, so once we have done that, now how to actually find what is happening? If someone directly asks you to into 14 without these many things, how to do that? So what I noticed, this 12 and this 4 add up to 16, and this 2 multiplied by 4 gives 8. Similarly, it is happening here as 12 plus 3 gives 15, and 2 into 3 is 6. Having said that, all of you might be knowing about the map of Africa, the physical map, isn't it? How does it look like? It looks like something like this. This is the physical map of Africa. This map of Africa would actually help us a lot. 12 multiplied by 13. Now understand this part. I hope all of you are aware about the geography. Whatever is inside the mainland of Africa, that would be added. 12 plus 3, I got 15. Cool. After that, whatever is on the Nile River goes like this. We have to multiply that. 2 into 3 is 6. And that's my answer. Isn't that interesting? So there are multiple ways to look at mathematics. It can be imaginative, it can be artistic, it can be geometric, it can be a lot of visualization. But all in all, we need to understand what exactly is happening over here. Let us try for a few more examples. If I write 14 multiplied by 12, now look at this. Whatever is inside the mainland of Africa, that has to be added. 14 plus 2 is 16. And on the Nile River, 4 2s are 8. That is the answer. Right? Let us take a few more examples. 16 multiplied by 12. now we will be having a problem. 16 plus 2 is 18. 6 multiplied by 2 is 12. Now the problem is 12 has got 2 digits. And as you can see, here we have only 1 digit. Whenever we have 2 digits, then comes the concept of carry forward. 2 remains, 1 goes here, becomes 192. So these are certain things which I saw in almost all the multiplication tables, and then I realized that we can create a theorem about it. Let's do that. Let's talk about the theorem now. We have got the logic, we have seen the pattern. By the way, mathematics is defined as the study of patterns, study of organic and natural patterns. That is what mathematics is all about. People might say mathematics is about expressions, variables, equations, algebra, geometry. Not really. It's all about, it's the study and analysis of patterns that we have in our all across the world. So I'll just tell you the theorem behind it, and then I'll tell you something really interesting and fascinating, which will help you realize that mathematics is all around you. Okay, let's talk about theorem first.
Sir, please switch on the captions, children. Yeah. Yes, sir. Sorry, please continue.
Should I go slow? Like my tempo of voice, should I go slow?
Sir, speaking alone a bit slow, sir, just to bridge the language.
All right.
Since it's supported by a board, I'm sure they are following it. I'm able to see that they're following it. Just thank you.
Sure. Well, so let's look at the pattern. I'll take 2 examples. There's 12 multiplied by 13. So what you need to do, both these numbers are near to 10. 10 is the base of these numbers. 12 is 2 more than 10. I'll just write plus 2 over here. And 13 is 3 more than 10. I'll just write 3 over here. Now, I can add 12 to 3 or 13 to 2. Both ways. You get the same answer. 12 plus 3 or 13 plus 2, you get 15 in both cases. And then 2 multiplied by 3 is 6. So you get 156 as the answer. But this thing can be extrapolated to any kind of number. Let us take 3 more numbers. 15 multiplied by, let's say, 13. This one is 5 more than 10. This is 3 more than 10. 15 plus 3 or 13 plus 5, you get it in both the cases. 5 multiplied by 3 is 15. And as I said, only 1 digit is allowed. 1 should be carried forward, and you get 195 as the answer. So this is quite magical. But the limitation is both the numbers should be in the same base. That is, both are near to 10. What if the numbers are in base 20? Let's talk about that. So if I take something like 22 multiplied by 23, here the base is 20. 22 is 2 more than 20. 23 is 3 more than 20. Doing it the same way, 22 plus 3 or 23 plus 2, you get 25. The only difference is, as the base is 20, you need to multiply the sum by 2. That's it. And everything remains same. In case of 10, we just add it. In case of 20, we are adding as well as multiplying that by 2. 2 3s are 6, the answer is 5. 2 and 25 is 50. 5 and 6 becomes the answer. Well, so I'll ask you a question. That means, if the base was 30, what would we have done? Tell me in the comments. If the base was 30, what would we be doing then?
Students, you can reply in the chat. I will read it out to sir. Sir, normally during the session audio, we don't enable for the students because they are huge in numbers. Students can reply on the chat and I'll read it to you. At the end of the session, we'll open it, sir.
Okay. What should we be doing over here? If I ask 31 multiplied by 33. In case of 10, we just added. In case of 20, we added in crosswise fashion and then multiplied by 2. So in case of 30, what should we be doing? Add and then multiply by 3, because base is 30 in this case. Which is up to we get 1, 0, 2, 3 as the answer here. Is that right? Oh, we got it. So next question, if the base was 60, what would we have done? If the base was 60. remain the messages and we'll be moving forward then.
So the base has to be 50. I mean, if it's 60 or so, the base has to be 6 then.
60, so we'll just multiply it by 6.
By
6. For example, we have 62 and 63. There's 2 more than 60, there's 3 more than 60, 62 plus 3, or 60 plus 2, 65. We need to multiply this thing by 6, and everything remains same. So 3906 will be the answer. Anyways, so I think this has given you an insight into how numbers multiply and what is the pattern which always remains intact in all sorts of numbers. As it is a long session, so we won't be going much into details of other numbers, but this will just give you an insight if you start practicing it. I know this is the first time that we're saying it, probably it looks very weird, but once you start practicing, that is something which you have to do. Just practice on 10 or 20 numbers and you will be Ashok just give the answer. Well done, Ashok. 3906. Yes. So if you keep on doing it, you will be more confident and highly capable after that. So now I'll be talking about numbers are everywhere. That will be the last part of the session. Everywhere, as said, mathematics study of patterns. So there are certain patterns which all of us should know about. A very interesting pattern, which I think in this limited duration would actually excite and interest you, is.
so one student has replied the answer as 3906 for the
Yeah,
that
Ashok.
word.
Yeah, that was Ashok. I
Right.
congratulated him. Well done, Ashok. Now, there's one thing which you will feel is impossible to define through mathematics, that is beauty. Well, beauty also has a mathematical definition. Do you believe in that? Sounds weird. As I said, mathematics is everywhere, and I also tend to say that mathematics is the language through which God talks to humans. If God exists, he or she or it has created this entire world. And all the world has been created through some kind of shapes, some kind of ratios are always there. So once it happened, that I was kind of very much interested to know that how people think that something is beautiful, something is not beautiful, something is right, something is wrong. Everything should be having a mathematical explanation, isn't it? So when I kind of went more into mathematics, I realized that there are certain shapes of faces or bodies which look attractive to all of us. I'll just discuss that. So whenever someone asks you, am I beautiful? You can do one thing. This is the face of a human, their eyes, nose, and lips. Look at this. So what I'll do, I'll just draw a line over here, across the eyes, middle of the eyes, tip of the nose, and tip of the chin. If this length is, let's say B, and this length is, let's say A, then the ratio of A and B would be close to 1.678 if the face is beautiful. So closer the ratio, the more beautiful the face is. There is something which is called as golden ratio in mathematics. Now, where from this golden ratio has come? I discussed that. By the way, according to this, the most handsome face in this world is of Tom Cruise, the actor. In terms of body, so you must have seen the painting by Leonardo da Vinci. He made something like this. There was a man standing like this, and from head to shoulder, if this is B, from shoulder to tip of the feet, if this is A. So A by B, if it is close to the golden ratio, the body would look more fit, more physically active, and more beautiful. This was what Da Vinci did back in 17th century. Well, so where from this ratio has come? Let's discuss about that. In our natural world, all of you should go, when after the session is over, go and watch a tree, a proper, fully grown tree, without any hindrances, without boundary walls. If it is growing in the forest, so tree goes like this. This is the inside the ground, the roots, then we have a trunk, and then we have branches. So now look at this. Here we have one structure. Here we have two structures. Moving forward, this branch will divide into two branches, and this will not divide if we draw a parallel line. So here we have how many branches? 1, 2, and 3. Similarly, if I go upwards, this will divide, this won't divide, and this will divide. Overall, we have 1, 2, 3, 4, and 5 branches. 1, 2, 3, 5. It goes on like this, and the series that is made is 1, 2, 3, 5, 8, 13, 21, and so on. What is the pattern in this series? Any number is the sum of preceding two numbers. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. This is known as Haynes sequence. Haynes was a musician. And 200 years later, it was an Italian mathematician called Fibonacci. It's also known as Fibonacci sequence in the West. And in the East, it is called as Haynes sequence. Now think about this. Haynes was basically a musician, and Fibonacci was basically a biologist plus mathematician. So even a musician can see a pattern in the music he creates. So I'll tell you how the music was created through this pattern. Interesting, isn't it? It's everywhere. Even in music. People think music has got no relation to mathematics, but no, it has. Okay. I'll explain that. So let us say I am a music teacher and I want to teach you music. And what I'm doing, I'm using a short chord and a long chord in music. What does that mean? I'll just explain you. So if I hit this board once, this is a short chord, this is a long chord. So short chord is composed of one beat, a long chord is composed of two beats. All right. So I'm playing the music, and in between, I'm playing something music, I'm playing. I left one blank. And I ask you in how many ways can you fill the blank? You will say only one way. That is filling the short chord over here. Only one way. I play a music and I leave two blanks. I'll ask you in how many ways can you fill it? There are two ways. Either you fill it with two shorts or one long. I hope it is clear. Yes or no? Is it clear?
Yes, yes, sir.
There are two blanks, either with two shorts or one long. So we have two ways to do the same thing. Now, if I leave three blanks, I can fill it with either three short, one short, one long, or one long, one short. Overall, we have three ways, right? That's also clear. 1, 2, 3. If I leave four blanks, see what will happen now. Fill with all short, or short, long, right? Short, long will be composed of two beats. Short, long, short. At the same time, we will also have one long, because we have four blank spaces. 1 equals to 5. Let 5 means. Don't you see the pattern is the same as what I drew with the 3? 1, 2, 3, 5. And now if I leave 5 blanks, I'll be getting 8 ways to do that. This is ancient sequence. This is a sequence found in trees as well. It was found by Fibonacci. But there's one more thing. If you count the number of petals in a flower, majorly 90% of flowers would be having petals which will be any of these numbers found. 1, 2, 3, 5, 8, 13, 21. If you count the number of petals in looks, lily, jasmine, you'll always find there are either 5 petals or 8 petals or 13 petals. Nothing else is possible in 90% of the flowers. Now, what does that mean? That means God talks to us in the language of mathematics, and everywhere around us, the patterns are there. I'll give you one more example. When we make a spiral, if we have students from mathematics background, there's a spiral, a circle whose radius keeps on changing. And this, a perfect spiral is the one in which if I consider this length to be B, this length to be B, and this length to be A, then A by B would always be equal to 1.618. This is the most perfect spiral which can be drawn in mathematics. Now this spiral is present in the entire universe. You must have seen the pictures of universe. The universe actually grows like this. A big bang happened a lot of years ago, And the universe is expanding, it's expanding in this similar fashion. And when it's expanding, all the lengths are expanding with a ratio of 1.618. That is universe. So golden ratio is present all across the world, in the living world, in the non-living world, each and everywhere. There are more examples, there are more patterns which can be you can observe. But having said all of that, and the limited time duration, I hope, and I think that you must have gained some kind of insight, some kind of, I won't say expertise, but some kind of icebreaker in which, if you think along the lines a mathematician thinks or an observer thinks, I think you will be very much well versed in the mathematics around you and all the competitions, be it CAT, GATE, banking, SSC, everything will be a cakewalk for you if you start observing things around you. Mathematics is nothing but observation of patterns. It's nothing more than that. So start learning mathematics, start learning your life. Thank you.
That has been wonderful, sir. Fully, it has to be 100%. The way we have to listen to it 100%. And I learned so many things today, like having crossed the school, college, and all stuff. But still, it was nice to see this golden ratio is so universal. It's just not limited to books. Thank you so much, sir. It was a very brief, packed session. I'm sure students will start learning to look at it differently now. Thank you so much for that. And the number of students still present, we have the same 200 plus bunch. So that really shows they were able to follow it well, and I'm very happy on that. May I kindly request Dr. Ravi, sir, from the college to propose the vote of thanks. Meanwhile, students, if you have any queries, please send it in the chat box. Sir is available here to clarify it.
This one thing which this one thing I would like to add, because it's a limited duration and we have there's a lot of things. It's very difficult for people to grab and absorb everything in one session. So I won't promise that I'm available forever, but in case there is something which you guys want to learn, you can just message me across LinkedIn or my Facebook profile. If I see it, I definitely reply to it. So I want to help all the people who have interest in mathematics, and I want to read interest people who don't have interest there. So I'm always available to online meetings.
Yeah. So Dr. Ravi, sir, can you please
Yes,
welcome me to
madam.
propose the vote? Yes,
Hello,
sir.
sir.
Thank you. Yes, madam. Good afternoon to one and all. On behalf of all students and staff, I am glad to say here to express my vote of thanks. A special thanks to our chief guest, Mr. Abhishek Leela Pandey, sir. Your mathematics thoughts have really truly inspired us. I thank our beloved principal for conducting this program, and I thank all the RUSA members, State Project Manager Dr. D.S. Vijayalakshmi Ma'am, Research Officer Dr. Vanadi Member, Consultant Mrs. Sivagami Ma'am, Junior Assistant Bhuvan Sir, and finally, I would like to thank all of you present here for making the time to be with us today and helping us make this event a grand success. Thank you to one and all. Thank you, sir.
Thanks a lot, Ravi sir. I'm really glad to have this opportunity. I love talking to people when you talk about it is about mathematics. Thank you.
Yes, sir. I think it's really a students from somewhere. Today I've been privileged to listen to you, and thank you so much. Sincere thanks from Rusa for agreeing to this session in spite of the schedule. Thank you so much. Students will be sharing a feedback link, and we are curious to know how you felt about the session. And this will be uploaded in our YouTube channel, sir. And it will be accessed. It's open for access for all the students of the social media. Thank you so much, sir. My sincere thanks to the college principal, coordinator, and faculty, and the staff, students, in making this session a good one. Thank you so much.
Thanks a lot, everyone. Thank you, everyone. I don't remember the names of everyone, but yeah, from whatever I can gather, I'm thanking heartfelt thanks to each and every one of you. Thanks.
Thank you, sir. Thank you so much.